Hello students, you are welcome to the YouTube channel Physics for Everybody. So we want to continue our discussion on motion graphs. Now the graph shown on the screen here is a velocity time graph. The vertical axis shows the velocity and the horizontal axis shows the time. So you can see the first part where we have the curve going upward is the velocity. Let me share my screen so you see what I'm talking about. So as you can see this graph here, this steep slope up here on the left-hand side shows the acceleration. This is what I'm talking about. This part here shows steady acceleration. Why? Because it has a positive slope. So when you have a positive slope this way, it shows that the body is accelerating. Okay, but when you have this part that is flat, it shows that there is no acceleration. No acceleration means velocity is constant, okay? So this part here shows that the velocity is constant. If you produce dotted lines backward, you get the constant value of the velocity. Yeah, if you produce dotted line backwards, you get the constant velocity of the body. Let me go back to this slide. So here, if you try to trace the graph backwards to get the constant velocity, you get 3 meters per second. So that shows that the body is not accelerating. While the rightmost part of this diagram shows that the body is decelerating. Deceleration means that the speed is reducing with respect to time. And that is what we have on this right end here. This shows deceleration down here. Okay, so the left side shows acceleration. This flat end shows constant velocity. If you trace the velocity backwards, you get to 3 meters per second. So from 2 seconds down to 5 seconds here, the velocity is constant. That shows that the body is not acceleration. That shows that the body is not accelerating. So when velocity is constant, we say acceleration is 0 meters per second squared. So let us see how we can solve question on this. Let's assume we are asked to calculate the acceleration within the first 2 seconds. So this is the first 2 seconds. From here to here is the first 2 seconds. So the time is 2 seconds. So what is the acceleration? So we pick the velocity here. Okay, at the end of this slope, the velocity here is 3 meters per second. So our acceleration is change in velocity divided by change in time. Some books say acceleration is equal to final velocity minus initial velocity divided by time. Any of those two formulas can be used. So let me use this formula, final velocity minus initial velocity. So when the body is accelerating, the final velocity is 3 meters per second. Okay, this is the final velocity, 3 meters per second, when we have acceleration. So we have 3 minus, what's the initial velocity? That's the velocity in the beginning of the journey, and that's 0, divided by time. What's time taken? We said the first 2 seconds, so our time is 2 seconds. So 3 minus 0 gives us 3. If you divide it by 2, you get 1.5 meters per second squared. That is the acceleration of this object within the first 2 seconds. Now, let us assume there's another question that asks us to calculate the deceleration. Which formula will you use to find the deceleration of the body? First of all, where do we have deceleration? We have deceleration we have deceleration from 5 to 8 seconds. That means there was deceleration within the last 3 seconds. Yes, there was deceleration within the last 3 seconds. So if you were to calculate the deceleration, you can see here we have steady deceleration, which is from 5 seconds up to 8 seconds. So how do you calculate deceleration? The same formula. Do not forget that acceleration is final velocity minus initial velocity divided by time. So we can calculate our acceleration and multiply our answer by -1. That gives us the deceleration of the body. How do you calculate acceleration? V minus u divided by t. So the final velocity is the velocity down here, okay? And the velocity down there is what? The velocity down there is the final velocity is the velocity down there, and the velocity down there is 0 meters per second. So our final velocity is the velocity down here at the end of motion. That's the velocity at 8 seconds. So with this, yes, our final velocity is velocity at 8 seconds, which is what? Which is 0. Okay. You can see this line here is the velocity axis. Yes, this line on the left-hand side is the velocity axis. The vertical axis shows velocity. And velocity at 8 seconds is 0. Yes, that's velocity at 8 seconds. Because at 8 seconds, this slope here is on 0. Yes, so when this line hits this 8, it hits 8 at 8 seconds, our velocity is 0. Because this slope is coming down to 0 at 8 seconds. That's why we say our final velocity is 0. And our initial velocity, that's we have deceleration from 5 seconds to 8 seconds. Yeah, so our final velocity was peaked at 8 seconds. Our initial velocity will be peaked at 5 seconds. And what's the velocity at 5 seconds? That's the value we have here. And the velocity here is 3 meters per second. Okay, yes. 3 meters per second is the velocity we have at this point. So our initial velocity is 3 meters per second. So let's go. Our final velocity is 0. Our initial velocity is 3 meters per second. And our time, what's the time duration? From 5 seconds to 8 seconds, how many seconds do we have in between? It's 3 seconds we have in between. Or you just say 8 minus 5. That gives you 3 seconds. So 0 minus 3 gives us minus 3. And 8 minus 5 gives us 3. That means our acceleration is equals to minus 3 divided by 3 gives us minus 1 meters per second squared. But take note that we have to calculate the deceleration. Okay, so deceleration is equal to negative acceleration. Hence, your deceleration is minus 1 meters per second squared. Minus of minus 1 will give you 1 meters per second squared. So our deceleration is 1 meters per second squared. Now, if you're asked to calculate the maximum velocity you do not need to calculate. Maximum velocity occurs when this slope is flat. So let me erase every other thing here so that you can see what I mean when we say the slope is flat. What do I mean when we say the slope is flat? That's the topmost part of the slope. And the topmost part of the slope is 3 meters per second. Yes, so this topmost part, that's where you have the maximum velocity. And if you trace it back, you get 3 meters per second. So our maximum velocity is 3 meters per second, rather, not 3 meters per second squared, 3 meters per second. Velocity is measured in 3 meters per second. Velocity is measured in meters per second. So our maximum velocity or our maximum speed is 3 meters per second. Now you've been asked to calculate the total distance covered. So this concept might be new to many of you. So when you have a graph and you're asked to calculate the total distance covered, how will you calculate total distance covered? Now we calculate total distance covered from the formula for speed. Now let's bring back the formula for speed into this situation. What formula do you use to calculate speed? Or what formula do you use to calculate velocity? Take note that this class is for IGCSE, so we can consider speed and velocity to be synonymous. That means they mean the same thing. The only difference is that velocity is speed in a specified direction, okay? But we're not interested in the direction here. We are not interested in the direction. Take note that speed or velocity is total distance divided by time. If I introduce a denominator of 1 here, and then I cross multiply, what will I have? If I introduce a denominator of 1 and I cross multiply, what will I have? I will have distance we multiply by 1. I will have distance is equal to velocity multiplied by t. I will have velocity multiplied by t. So this is the formula for calculate distance, okay? So if you look at this graph, the value you have on the velocity axis multiply by the value you have on the t-axis. That gives you the total distance covered. But you can see that this is not a shape where the lower and the upper parts are of equal dimension. What formula do you use to find the area of a trapezium? We use half open bracket a plus b multiplied by height. So this half, we are finding the average of the top and bottom width. When you get the average of that, just multiply it by the height. Where is the height? The height is this vertical distance from top to bottom. Okay, this is the height. And this height is what? Is 3 meters per second. Yeah, if you pick from here. So you can see that the height is 3 meters per second. A is from this place to this place up here. This is our A. And B is the lower one. This lower one, B. So to find the area of a trapezium, you find the average of A and B. So half of A plus B. Okay, when you get that value, just multiply by the height. And that gives you the distance covered. Okay, in this graph. So let's solve that. Half open bracket. What is A? A is from 2 seconds to 5 seconds. What's the time taken from 2 to 5 seconds? That was 3 seconds. That's the A. A is 3 seconds. So this is our A. The top part, I've erased that. This top part is our A, and we have our A as 3 seconds, okay? Because A is just these upper parts. And B is down here. B is from 0 up to 8 seconds. So that's our B is 8. Multiply by our height. What's our height? Our height is 3 meters per second. The height is from this line down here up to this topmost part. Okay, and we have that as 3. We have that as 3, which is what we have here, 3. So our height is 3. Let me erase the line so that it does not become confusing. Okay, so let me go ahead and solve with these values I've substituted. How do we get our distance? Let's solve. So have open bracket 3 plus 8 close bracket multiplied by our height. Let me write the value of the height there. Our height is 3, so I don't need to put h there. I'll put 3 here. So now we have half open brackets 3 plus 8 is 11. 11 multiplied by 3. That will be half multiplied by 11 multiplied by 3 gives us 33. So if I multiply half by 33, I'll get 16.5 meters. That gives us the total distance traveled in the journey, or that's total distance traveled represented by this graph. Let us solve another question on this. Look at this graph here. This is a velocity time graph, and you've been asked to find the acceleration within the first 10 seconds. So within the first 10 seconds, that's from 0 up to 10. Which formula would you use to find the acceleration? Acceleration is equal to final velocity minus initial velocity divided by the time taken. What's final velocity? You know, within first 10 seconds. So at 10 seconds, on the velocity axis, we have 40. So our final velocity, so A equals to our final velocity, which is 40, minus our initial velocity. Our initial velocity is velocity in the beginning here, which is 0, divided by the time taken. What's time taken? The time taken is 10, because we said the first 10 seconds. So our time taken is 10. Good. So our acceleration is equal to 40 minus 0 gives us 40, divided by 10. 40 divided by 10 gives us 4 meters per second squared. Yeah. So now we want to calculate our acceleration within the next 10 seconds, or from 10 to 20 seconds. Okay, from the time stamp 10 seconds to 20 seconds. Which formula would you use for acceleration there? The same formula, acceleration equals to v minus u divided by t. What's our V here? V is our final velocity, which is velocity at 20 seconds. What velocity at 20 seconds? We have 40 meters per second. So we have 40 minus initial velocity, that's velocity at 10 seconds. What's velocity at 10 seconds? At 10 seconds, our velocity is 40 divided by time. What's time taken? Time taken is 20 minus 10, okay? Yeah, because we are taking timestamp 10 to 20 seconds. So let's go. We have our acceleration equals to 40 minus 40, we have 0, divided by 20 minus 10, we have 10. And 0 divided by 10 gives 0 meters per second squared. So if in a velocity time graph, whenever you have this flat part that is not slant, just know that your acceleration is 0, okay? Your acceleration is 0 because your speed or your velocity is constant. You can see that this velocity is 40 meters per second throughout this part of the journey, okay? Before we now have another acceleration. Now, how do you calculate the acceleration here from 20 seconds to 30 seconds? You use the same formula. Acceleration is equals to V minus U over T. Okay, that means acceleration equals to, what's our V? Our final velocity here is 60. We have 60 minus, what's our U? Our U is our initial velocity here, and we have that as 40. What's our T? Our T is time taken for that to happen, which is 30 minus 20, and that gives us 10. So let's go. Our acceleration is 60 minus 40, that gives us 20. 20 divided by 10, that gives us 2 meters per second squared. So if you look at the graph, you see that the first stage of the motion, our acceleration is 4 meters per second squared. The second stage, our acceleration is 0 meters per second squared. The third stage, our acceleration is 2 meters per second squared. Let me erase all of these lines so that the graph will be easy for you to visualize. Let me erase all of this so it will be easier for you to visualize what I'm talking about. Okay, so that's what we have here. The first stage of the motion, our acceleration is 4 meters per second squared. The second stage, our acceleration is 0 meters per second squared. And the third stage, our acceleration is 2 meters per second squared. Now take notes of something about the steepness of the slope, okay? The slope of the graph. Take note about something about the steepness of the slope of the graph. When our acceleration is high, the slope is very steep. When acceleration is 0, the slope is not steep at all. You have a flat slope. And when acceleration is low, the slope is not very steep. This is what I mean. When our acceleration is high, for instance, let's assume the acceleration is as high as let's assume acceleration is as high as 100 meters per second squared. The slope could look like this, very steep, as if it's becoming straight. When acceleration is as low as 1 meters per second squared, the slope could look like this, okay, as if it is becoming completely horizontal. And when acceleration is as low as 0, the slope will be flat. When acceleration is high, here, acceleration is 0. Okay, when acceleration is 0, the slope will be flat. When acceleration is low, the slope will just slightly diagonal. But when acceleration is very high, the steepness of the slope will be very high, as if you are drawing a vertical line. Okay, so that's what we have here. When acceleration is 4 meters per second squared, you can see the steepness of this line. Can you compare it with the steepness of this line when acceleration is 2 meters per second squared? So you see that the one of 4 meters per second squared is very steep in comparison with the one of 2 meters per second squared. While the one of 0 meters per second squared is just a flat line. Take note that all these values are positive, plus 4, 0, yes, plus 0 or minus 0, whichever one. And for 2, plus 2. Whether it's plus 0 or minus 0, it will be flat. 0 is 0. But when the slope is going the other way, then our acceleration will be negative. Okay, our acceleration will be negative. Or you say we have deceleration. So, okay, let's calculate the acceleration here. Let's see if we get a negative value. Okay, and after that, we can now go ahead and calculate our deceleration. Okay, yeah. So as for where we have deceleration, it means our acceleration is a negative value. Let us solve the problem here. Now we are going to calculate the acceleration from within the time stamp 40 seconds to 50 seconds. What's the value of acceleration here? I'm sure you can solve this because we've solved something similar to this. So the formula, you start by writing the formula for acceleration. Acceleration is equals to v minus u divided by t. Okay, final velocity minus initial velocity divided by time. This is our initial velocity because we are starting from here. This is where our deceleration started. So our initial velocity is 60 meters per second. This is our final velocity because this is the end of motion. And whenever your line comes back to hit this horizontal line, okay, whenever the slope comes down to hit this horizontal line here, we say our velocity is 0 meters per second. That's the final velocity. So let's go with our acceleration. Our final velocity is 0 meters per second. Our initial velocity is what we have here, which is 60 meters per second. So you have 0 minus 60 divided by, what's the time taken? The time taken is from 30 seconds up to 50 seconds. And what's the time duration there? Just do 50 minus 30, you get 20 seconds. Hence, our acceleration is 0 minus 60 gives us minus 60, divided by 50 minus 30 gives us, our time is 20. So our acceleration is minus 60 divided by 20. That gives you minus 3 meters per second square. So you can see our acceleration is a negative value. Okay, so the slant slope, the direction in which the slope is slant is enough to let you know whether you have acceleration or you have deceleration. Now let's calculate our deceleration within the last 20 seconds, okay? Yeah, this is the last 20 seconds. From timestamp 30 to 50 is the last 20 seconds. So our deceleration is what? Minus acceleration. Put minus in front of this or minus 3, you get 3 meters per second square. That is the value of your deceleration. So this brings us to the end of calculation involving acceleration and deceleration. But is that the end of this question? No. What if the question asks you to calculate the total distance covered? You know, the formula to get the total distance covered in a graph, you have to find the area that is covered by the graph itself. How do you find the area covered by this graph? What shape do we have here? You know, then we can't call this a particular regular shape. So we can cut this shape into, probably you can have triangles and squares, or we can have triangles and trapezium. Yeah, or we have triangle, rectangle, and trapezium. So you just cut it whichever way is convenient to you, for you. So when you cut it, then you can now solve or calculate the area of each of the fragments you have there. Now let us cut this shape. I will cut this into a triangle. We have a triangle here. Okay, this is a right angle triangle. And the formula for the area of, let's just name this A. A is a triangle. Then we have another plane shape, which is B. And the plane shape B is here, a rectangle. Which other shape can we cut? You can cut a triangle. Okay, you can call this a triangle. Okay, if you don't want to call it a triangle, cut a triangle from here, you can cut it this way too. So if you cut it this way, this shape here, shape C is a trapezium, and then the shape D is a triangle. Now let's deal with the shape A. Let's solve our problems on the shape A here. Our shape A is a triangle, so the distance traveled within this period of shape A, that's within the first 10 seconds, is velocity times time. Okay, but we're not using velocity times time here. We are using half base times height, okay, because we are calculating the area of this shape here, this triangle. What's the base? The base is from 0 up to 10. That's the base, okay? So we have half multiplied by 10, okay? That's the base. The base is 10. What's the height? Our height is the vertical distance here. And how do you get this vertical distance? We can pick it from here, 0 to 40. This represents the height. This represents the height. So our height is 40. So if you calculate this, we get the distance covered within the first 10 seconds. Half base times height. What will you get? Half times 10 times 40. If you solve that, you will get 20. Yes, you get 20. So let me still put A here, okay? So that you know you are solving for the shape A. So half of 10 is 5. 5 multiplied by 40, you get 200, please. 200. So you have 200 meters for the first 10 seconds. Let me write 200 meters here. Let me just keep this here. Now, as for the shape B is a rectangle. And how do you find total distance covered? Just multiply the length by the breadth or the width. What's the length? Let's take this as the length. Okay. That's the height of this place. Okay. And what's the height of this place? This is 40. You have already taken this as 40. So our length is 40 multiplied by our breadth, that's the distance from here to here. And what we have from here to here? That's from 10 to 20. Hence, we have 10. Okay, because 20 minus 10 gives us 10. Now, you multiply 40 by 10, you get 400 meters. That's the distance covered within the shape B. Now, C is a trapezium. And what formula we use to find the area of a trapezium? So C is a trapezium. The formula for area of a trapezium is half open bracket A plus B all multiplied by H. Now, what is A? A is the height of this place. If you look at this trapezium, this is our A, which is 40. So we have half into 40. Okay, please, just in order to make this easier for you to visualize, you can draw the trapezium like this, okay? These are A, these are B, and this vertical distance is our height, okay? Now, this trapezium, if you rotate it anti-clockwise by 90 degrees, you have, if you rotate it anti-clockwise by 90 degrees, you rotate it about this axis, you have this very shape here. Yeah, so this is our A, this is our A here, this is our B, and this is our height. So our height here is from 20 to 30, which is 10 seconds. What is the height? What is our B? What's the value of our B? Our B is the value we have here, and the value we have here is 60. Okay, so let me erase all of this so you can clearly see what we are talking about. Okay, so now you can see that our B is 60. So I put 60 here. So I put 60 here plus 60, close the bracket. Our H, that's the height, our height is 10. So you put 10 here. Now let's go. We have half open bracket, 40 plus 60 gives us 100. Close the bracket, multiplied by 10. Now let's see, half multiplied by 100 multiplied by 10, that gives us 500 meters. So at C, our distance is 500 meters. Now let's deal with the shape D. This is the base from 30 to 50. Okay, so our base is from 30 to 50, which is 20. And our height is from this point here to this topmost point, which is 60. So the area of D is half base times height. So that will be half multiplied by our base is 20, multiplied by our height is 60. Why are we using this formula? Because the shape of D is a right angle triangle, is a triangle. Okay, so let's go. Half multiplied by 20 multiplied by 60, that will give us 600 meters. Now, if you want to calculate the total distance, now add the area of A plus area of B plus area of C plus area of D. What does that mean? That means we do 200 meters plus the area of B is 400 meters plus area of C. The area of C is 500 meters plus area of D is 600 meters. 600 plus 400 plus 500 plus 200, that gives us 1,700 meters. And that's how you find the total distance covered. So the total distance covered is the area of the shape formed. Once you calculate the area of the shape formed, you have the total distance covered. So that brings us to the end of this discussion. Thank you for listening. You have a nice day. See you in the next class.